We have experience.
Supervised learning.
Yes or no? We have some experience observed. That means that's one kind of supervised learning. We have learning 14 times. Okay? We have learning 14 times. But from our look, temperature, humidity, winding, my question is, which one can help you decide they will choose yes? Let's go to play roll. Which one is more important? Most important. 14 times observation. Maybe it's not enough. But how about 140 times, right? Okay, this is more reliable. Yeah, more confidence. You observe 114 times, maybe 1,400 times. Okay, I suppose they have a very standard criteria to decide, let's go to play golf or cancel. 如果你观察了不是14天，观察了140次，观察了1400次，他们一定有一个俱乐部的组织，他们到底要不要出去打高尔夫球？ If you observe 140 times, 1,400 times, the decision based on what? Based on previous experience and the case. But only 14 cases is overloading for human to observe about it, right? Right? Only 14 cases. 只有14次你都很难找出它的准则。 Only 14 cases. You are still difficult to find questions about what our here. Yeah. Go down. Go down. Okay. You can take a picture about this. No matter. All of this is about maybe 20 years ago. Different criteria, different algorithm development. Okay, info. That's it. Yes. Please info your case. But in our case, temperature and humidity, they are numerical data. In our first chapter of C4.5, okay, the example is that they based on the game. You open the data file and they will be in your workspace, okay? Or you want to open workspace and open data file, doesn't matter. So you choose the data file and choose the node browser. Node browser, you can choose the data mining here, extend it. And it belongs to first one tree partition, right? And you can choose the card CNRT there. Okay? And enlarge your box. So in CNRT, you have a general standardized classification tree is based on SVD. And continues our temperature and the humidity, right? Two of them, yes, together. Together, control. Already? type of control. Choose 2 of them. Ultra type 3. And categorical predictor. Yes, your outlook. You must choose outlook. Yes, outlook. Maybe right. So stop here, right? Temperature is always low, not so important. Temperature. 温度啊，是这4个里面最重要的，不是主要的。So what is the count available? You can count maybe that's a weekend or yes.
Actually, days are unavailable in this case.
Yes, they don't want. It's a day. Doesn't matter. 14 days, or you want to count this.
But in this case,
which crowd or male or female or weekday or weekend?
but in this case, do we even need it?
Yeah, you don't need it. Just push OK here. And set the code.
Okay,
Outlook is all, right? Is all.
categorical.
A response code is all. Just yes and no, right? You can do it. You can do it. Just 2 level, right? It's just up here. And yeah, sometimes you can choose just 2 kind of species or 4 kind of species together. Or if you just maybe you can choose the most difficult 2 kind of species. And the final process. Here it says they will produce the code, the coding, something that is program coding for you. Okay?
3 graphic Lego, number of terminals, 5.
Yes, you can
CRT.
use a way. Doesn't matter, you can use the other traditional way. This
okay,
just
I need
workspace. Traditional way is the same.
Number of variable, number of observation in 1 to
Traditional way just step by step. You can see the paper step by step.
temperatures.
You didn't choose the tree. You didn't choose the tree.
This is the tree layout for Lego. 1, 2, 3, 4, 5, 6, 7. So we have
You
9.
didn't choose the tree step. Tree browser.
For node 1,
Go back
2,
again.
1, 2, 3, 4. 1, 2, 3, 4.
I mean the quick.
Terminal node 5.
Yes, tree browser. Yes. Or you want to see the step by step of scrollable tree. Okay? And the importance. You see? The importance. Yeah, and the importance will let you know which criteria is more important.
Wow.
Yeah, and go back to see your results step by step tree. So at original risk estimate. Or go back to interactive tree.
think
You can choose another.
but it stops after the first node, so that's why this looks so weird. Because there is no two nodes.
Oh, okay, two nodes.
Yeah, because the first one, no, yes, and then it stops.
Oh, yes.
Node 1 yes, node 2
So
node 2.
you can choose the interactive tree. Interactive tree.
So the variable outlook will split.
Delete it. Yes.
Node 2
You can delete
have
all.
on cast, node 3
Delete
summary
all
or
the
learning.
stuff. Yes, just cut it. Delete it. Yes, delete it.
Node 2.
Choose the interactive tree. Yes, I tree. I mean interactive tree.
Yeah, that's true.
Oh, okay. We'll use the car. Car. Okay, stand
Try
line.
the general.
Okay, general tree. Okay, stop here. Stop here. Ending. Yes. Okay, stop here. Yes, you can compare different kind of card, general 或者 standard， 你可以比较不同的 card。And double click. Teacher computing the result. Which one is based on 4.5?
Choose the variable. I click on variables. First, the one thing that we always need to know is the data type. Otherwise, once this Windows gets open in front of you, you don't know which one to choose. Now, I already know my dependent variable is playing golf. Is it a numerical variable?
No,
Is it a numerical variable?
it's categorical.
No. It has only two answers, right? Yes and no. So what kind of variable it is? It's a categorical variable. It's not continuous, right? Right? Therefore, I choose my dependent variable, label, as a categorical variable. Now the predictors. You can see I was asking where is my data set so I can check again which one is continuous, which one is categorical. Now, the day is a count variable. I don't need that variable. So, in terms of predictor, my continuous predictors are temperature and humidity. Because both of them are numeric variables. But they are kind of interval data type, right? But they are continuous variables. Do you understand? I want all of you, if you don't really know what data type is, please go on YouTube, go on Google the data types, continuous, binary, numerical type of predictors are outlook and window.
Yes. Card. This algorithm is preferred for continuous data, okay? Maybe you can identify the looks. One is for sunny, two is for overcast, three is for raining, okay? One is for windy, and two is for strong, windy.
Codes. Play golf only has two codes, so I'm going to select all of them. If I want to see them, I can zoom to see. Okay? I can see it's yes and no. And I can go OK. And for the predictor variables, we can check all the codes. Outlook, Professor just mentioned about Outlook and Windows. All the codes. If you want to zoom to see, rainy.
Only raining?
Actually, we have three outlooks.
So,
We have overcast, sunny. I'm not sure why it's not showing up.
so maybe you had something wrong?
In my case, Professor, it is showing overcast, rainy and sunny.
Yes.
It should show all of them.
Yeah. So your data, maybe something wrong?
Yeah, maybe something. You have a node that is homogeneous or that is pure with 100% yes or 100% no remaining, then they cut. You understand? Now, if we take this as an example, we have, for Outlook, we have both yes and no. That's why two nodes are generated. Remember, we say for CNRT, every time two nodes only are generated. So
CNRT,
two nodes are generated.
two nodes are generated.
And this is for overcast. Remember, in the example Professor showed, overcast had 4 yes and 0 no.
4
If
years,
you remember earlier,
0
and
no.
there was no more rule generated from there. Do you remember what Professor showed on the board? If I can bring back the PPT. There we go. Overcast. Yes. And stop. Because it was a pure node.
A pure node. This is a pure node.
Okay? Now, humidity and wind, they were not pure nodes, so they analyzed. Now, strong, no. Yes. No more nodes generated after that. Now, let's go back to our CNRT result. Now, for temperature, okay?
If the temperature higher than, lower than 70.5, well, most of it will be yes, a little will be no. So this temperature is easy to cut based on temperature. Okay.
And we can see for a temperature higher than 77.5, most of them are no. I mean, all of them are no. So there's no more node generated there.
Stop it here.
Every time that you have a pure node, the splitting stops. No more nodes are generated.
Pure node. This is also a pure node.
Okay?
And pure.
We can check the rest of the other results. We can check the tree structure. Okay. Left branch, right branch, node 2, 3, size of the node 14. Every time the size of the node is medium. Okay? Number in class number and number of cases in class. Okay? 5, 10. And selected category. Yes, yes. So what are the split variables? It's outlook and then temperature. And what are the split categories? Yes. Let's see the classification matrix. Predicted no, 3, observed yes, 0. Predicted yes, 2, observed yes, 9.
There's a diagonal is you are predicted correct. 9 and 3 and 9 diagonal. So 12 cases are correct. Only
12
2
cases
cases
correct.
predict error.
Okay, two
The
case predict
diagonal is correct.
If you remember the
We are total 14 cases. And 12 case predict right. 2 case predict wrong.
you remember the result here. Only 2 are incorrect.
Only 2 are incorrect. That's a really result. That's your predict. There's a no, but you predict yes. There's a no, you predict yes. Okay? Based on your learning, your training, only 2 you predict error. Okay? So your correct rate is 14 over 12, right? 你的正确率是多少？12除以2、6、12、2、7、14。6 over 7.
All of this is correct, except 2 cases, number 8 and number 14. Predicts wrong, right? Also the new isn't correct, it's the same, so it's right.
你发生在第7个 no.
Except 2 cases,
Determinant
so 12 cases right, 2
no.
cases wrong.
Can find the result. You can
That's
find the
why
tree at the ID7. The 7.
No, this
The
one.
7's no. You can find this stuff here.
Just
The
close
7
now.
one. You can see the tree.
That's why you can see here 12 cases is predict
Yeah,
right,
the 7.
2 cases predict wrong.
Okay, they classify these 2 cases finally. Find
So basically this trap is correspond to this trap.
the no
1, 2,
7.
3, 4, 6, 7.
Okay,
Except
finally,
searching.
you can go home, try to the other case, or you want to open the iris. You can run the iris.
What is
again.
this talking about?
You are familiar with the iris. Give me 10 minutes. Please open the
Please
case.
open the iris data set from the
Example.
open example in Statistica.
Okay. Open iris.
再打开原本画那个案例。Yes, you can go home, try the other card or chart. You can use the chart to practice this example, okay? But now we want to introduce another example is our iris. Yeah, no, just iris data. Why? Because card is very preferred for continuous data. So you can just choose there, not go to workplace from the computer. Just data mining. Just choose the data mining there. You can use this way. And to choose the interactive tree.
Okay, so this is a classification analysis that we are running, and we are doing the CNLT example.
Classification.
Now we're going to choose the variables. We only show the appropriate variables. Now, what is our dependent variable, everyone?
Iris type.
Iris type.
As you remember that case, right? We based on the petal and the sector length and width. We want to identify 3 kinds of iris. But yes, answer me the question: which variable are stronger? Is the best one to identify 3 kinds of species iris? Can you tell me again? Do you remember?
Okay. So for the response code, we selected them all. Okay. All. I hope I'm not going too fast, right?
Yes. Yes.
It's too
I'm going
fast.
too fast?
Yes.
Go back. Okay. Go back. Go back. Go back.
Okay, just stop here. Just stop here. Stop this one.
Interactive
For
tree.
our classification, analysis, and this for card. Okay?
And we click on OK.
Okay.
This is the default already.
Yes.
Okay. Now we are going to choose our variables.
I choose.
We show only the appropriate variables. That makes it easier for you. So we already know the dependent variable is iris type, right?
Yes.
Okay. And we know our continuous predictors, right?
Yes.
Okay.
But your iris give him the label 1, 2, 3.
Yeah, it's already there. We're gonna choose it.
Yeah.
So the response code.
Yes. I mean the average type. You name the code. Yeah. 1, 2, 3. Yes.
It already has the code.
Yes. Yeah. You have better the 1, 2, 3.
Yeah, it already has it.
Numerical.
Yeah. Okay. So we choose all, and we click on OK.
And cross validation if you want.
Or you can select default cross validation.
Yes.
What are my parameters? 1 and do we cross validate the sequence? No. This one we don't. But the stopping moves. I think we can use the default. For the advanced, we also use the default. I mean, the number of small is
Yes.
so we click on OK.
Okay, and you can find all the results. You can see the tree graph. Okay.
You can see the tree
Tree
graph.
graph or tree browser, all the importance. Okay, step by step.
So the first thing, we want to see the tree graph. This is our tree graph.
That means Setosa based on the petal length. If the petal length less than 2.5 inch, there will be all of them are Setosa very clearly to identify. You know what I mean? Just based on one criteria, the petal length smaller than 2.45 inch. I have 100% confidence.
That is
You know,
Setosa.
this iris species is Setosa. Because each species technically sample size. Okay? 每一种的原本花有50朵，只要它的花瓣的长度小于2.45英尺，它100%都是。
Just to remind you, because Professor reminded that we always need to give some background story. This data set has 3 different iris types for the flower and 50 from each class. Okay? The parameters that were measured was the petal length and width, and then the sepal length and width. Okay? Now, based on how long the petal is, okay, talking about the length, based on how long the petal is, if it's lower than 2.45, all the iris that will fall into this category, we have 100% confidence they will be Setosa. Now, anything higher or greater than 2.45 in terms of length can be you can use a different criteria to classify them, because there are more than one type that falls into this category. Now you're going to use the petal width. Okay? You're going to see how wide it is. Now, based on how wide it is, we already know 100% probability for Setosa already gone. So now we have 100 cases remaining to classify 100 cases remaining to classify between versicle and virginate. Now, if it is lower than 1.75 centimeters wide, lower than 1.75, we find 54 cases that can be either versicle or virginate. Either versicle or virginate.
But versicle take blood part.
But versicle take the highest part. Because remember, each group has 50. Now if you have 54, then it's more than one group together. Right? Understand? But for virginate, if it is more than 1.75 centimeter wide, everything that falls into this category is virgining. Now, there are some virginings that might not be as developed as the others, and in terms of how wide they are not as wide as the regular virgining, so 4 of them fall into this category. That's why 2 more nodes will be generated, and the criteria to decide between them, the difference between them will be the petal length. Right? And that's where we have 48 cases that falls into versicle based on the length of the petal lower than 4.95, and 6 cases, let's say misclassification, that would be considered as a misclassification, but at this point we could still have 1 more node to see which one, but we don't have any more criteria left.
You see, not 100%. It's impossible, not easy. But actually, you don't need to ask your boyfriend is 100%, right? It's not easy. You see?
Okay. Okay, we have.
You see the diagonal is correct. Predict. But beside upper or lower the diagonal, there's a wrong. Predict wrong. Okay?
Yes, 4 cases.
The yellow.
Very
But
wrong.
change the color of the red. Not easy.
So the case number 147.
Okay, but the one
25,
is
so,
okay.
and
Look here. What is one? If original is observed is virgining.
Okay.
What we predict as a versicle.
Here we have what has been predicted, okay? And on the horizontal, we have what has been observed, okay? Normally, we predicted Setosa 100% right. But for vertical, we predicted 48 to be vertical, but actually we observed 47 are vertical and 1 is virgining. Just like we also predicted virgining, 52 virgining, but we had 3 of them being vertical and 49 of them being virgining. So there you can see where you had the misclassifications.
My problem is if you are vertical are easy to be misclassified as virginic, or if you are a virginic, easy to misclassify into
Vertical.
You know what I mean? In my question, if you are a male, easy to tell as a female, or if you are a female, easy to tell as a male. Which way will be higher mistake? You know what I mean? This here. Only one mistake. If you are virginic, only one mistake we see as a vertical is lower, right? But if you are a vertical, you have 3 times be misclassified into virginic, right?
It's more, have more problems.
2 kinds of species. A be easy misclassified into B, or B will be easy misclassified into A. Is different, right? And they will show the probability here. Okay? For this one, original is vertical, and we misclassify predict as a virginic. Why? Because they predict this as a virginic. The probability is 66%, higher than the other, higher than 33%. Okay? 这一朵啊，被误认为 virginic probability is higher than this, so that's why I predict as a virginic. Okay? Based on probability, to decide your classifier.
Statistica, I have 79, 70, almost 75%.
So how many is that? 4, right?
Probability to classify as a
4
business.
is that. Number 71, number 78, number 84, number 107. Understand? So maybe that's your 9, 12, 25, okay? Random. Your result and mine maybe not in the same spiritual, okay? They are randomized. 你的顺序结果跟我的那个 case number maybe 不一样哦。Probability, okay? Your prior probability have better balance. Do you remember our last case, male and female? 男生只有82 percentage, female only 80 percentage, right? So it's not easy
This is a
to
good
observe
data set.
the female behavior or habit. But in this case, your species is the prior probability is the same. Okay? But I agree, some situations, some real case, their prior probability is different. Some birth rate for the boy birth rate maybe only 20%. If you want to give the penalty, if you miss the question wrong, sometimes they will challenge or give you penalty, charge your money, or give some penalty. So they will be heard and you will adjust your probability. You know what I mean? You can guess I am a male or female. If you are guessed wrong, I give you a very strong penalty. That means you must pay money, gambling. So you will be hurt. You will be lower down your probability. That means cost matching. This prediction, they concerned about the cost. Okay? That means if you guess correct on the virginic right, I give you more money. Yes, I will be. Here's high probability for vertical. You know what I mean?